Test, test. Hey guys, Travis Gillespie here. We're working with divisibility in this next section, and we're going to talk about Hey guys, Travis Gillespie here. We're going to be working with divisibility in this next section, and we're going to talk about the rules of divisibility. Here's a list of all the rules of divisibility that we'll be working with. Now, a number is said to be divisible by another number if the quotient is a whole number without a remainder. So an easy way of saying that is a number is divisible by another number if you get a whole number as your result. Now we can find out, now as we work with more complex numbers, now these rules will come in handy. Now the rules that we're going to look at will come in handy when we work with more complex. Hey guys, Travis Gillespie here. We're going to be working with divisibility in this section. And here's a list of the rules of divisibility that we'll be working with. Now, a number is said to be divisible by another number if the quotient is a whole number without a remainder. Now, that sounds complex or a little bit long, so I'm going to shorten it. A number can be divisible or is said to be divisible by another number if you can divide it and get a whole number as your result. So let's look at this list. This list will come in handy. Hey guys, Travis Gillespie here. We're going to be looking at divisibility in this section, and we'll be looking at the rules of divisibility. Here's a list of the rules that we'll be working with. Now Hey guys, Travis Gillespie here. We're going to be working with divisibility, and in this Hey guys, Travis Gillespie here. We're going to be working with divisibility in this section, and here's a list of the rules of divisibility that we'll be working with. A number is said to be divisible by another number if the result or the quotient is a whole number without a remainder. Now, an easy way of saying that is a number is divisible by another number if your result is a whole number. So let's take a look at this list. This list comes in handy as numbers become more complex. So here are some simple rules to follow. The rule of 2 says that all even numbers are divisible by 2. So a number is divisible by 2 if all of the numbers are even numbers. So a number is divisible by 2 if that number is an even number. So all even numbers are divisible by 2. A number is divisible by 4 if the last 2 digits is divisible by 4. Let me give you an example. I'm just going to change pen colors. And I'm just going to write down here 3,512. So 3,512, notice the last 2 digits here, well, it's 12. 12 is divisible by 4. Therefore, 3,512 is divisible by 4. The rule of 6 says, hey, both rule 2 and rule 3 have to apply. They both have to work. If one of these rules doesn't work, the rule of 6 doesn't work. The rule of 3 says, hey, take a look at the sum of the... Hey guys, Travis Gillespie here. Hey guys, Travis Gillespie here. In this section, we're going to be looking at divisibility, and below Hey guys, Travis Gillespie here. In this section, we're going to be looking at divisibility, and below is a list of the rules of divisibility that we're going to be working with. I want you to notice, take a look at this list. Well, I've listed it as 2, 4, 6, 3, 5, 9. I just want to let you know, if you want your list to look Hey guys, Travis Gillespie here. We're going to be working with divisibility in this section, and below there's a list of the rules of divisibility that we're going to be looking at. Just take a look at this list real quick. Notice I've listed the numbers as 2, 4, 6, 3, 5, 9. They're not in order from least to greatest. I just want to let you know if you did want to order yours from least to greatest, so 2, 3, 4, 5, 6, and so on, you can. I've listed mine in these specific groups for a reason. It makes the process a bit faster. If you've got a different method that you like, use it. So a number is said to be divisible by another number if the quotient is a whole number without a remainder. Let me say that another way. I'm going to call this the Mr. G definition. A number is divisible by another number if the result is a whole number. So let's take a look at this list and see how these values apply or these rules apply. So the rule of 2, a number is said to be divisible by 2 if that number is even. Therefore, all even numbers are divisible by 2. Let's move on to the rule of 4. The rule of 4 says the last two digits, if the last two digits of that number is divisible by 4, then the entire number, that number is divisible by 4. Let me give you an example here. So if I had 3,512, notice the last two digits, well, it's 12. So I'm going to underline 12 just so it's more noticeable. Since 12 is divisible by 4, 3,512 must be divisible by 4 as well. The rule of 6 says both rule 2 and 3 have to apply. So if either rule 2 or rule 3 doesn't apply, if it doesn't work out, rule 6 won't work either. The rule of 3 says the sum of the digits is divisible by 3. Let me give you an example here. What if I had the number 231? So 231, well, the sum of these digits, if I were to take these digits and add them up, so 2 plus 3 plus 1, well, I get 2 plus 3 is 5 plus 1, that's equal to 6. And 6 is divisible by 3. So 231 must be divisible by 3. The rule of 5 says if the number you're looking at ends in a 5 or a 0, that number must be divisible by 5. The rule of 9 says the sum of digits is divisible by 9. So what if my number was 333? If I were to add these digits up, I'm going to fix that error real quick. All right, so if I add these numbers up, 3 plus 3 plus 3, well, 3 plus 3 is 6 plus 3, that's equal to 9, and 9 is divisible by 9. Therefore, 333 must be divisible by 9. The rule of 10 says the last digit is 0. So if the last digit's a 0, it must be divisible by 10. And the rule of 4 and the rule of 12 says the rule of 3 and the rule of 4 both apply. They both have to work for the rule of 12 to work. Here's an example. What if my number is 1,116? I'm going to look at the rule of 3 first. So the rule of 3 says I've got to take the sum of these digits. So 1 plus 1. So I'm going to take the sum of these digits. 1 plus 1. So I'm going to take the sum of these digits. So 1 plus 1 plus 1 plus 1. Plus 6. Well, 1 plus 1 plus 1 is 3 plus 1, 6 here, plus 6 is 9. 9 is divisible by 3, so the rule of 3 checks out so far. 12 might be divisible by this number, but I've got to check and make sure that the rule of 4 also works. So the rule of 4 says the last two digits is divisible by 4. Since 16 is divisible by 4, the rule of 4 also checks out. Therefore, 1,116 must be divisible by 12. Cool stuff. Hey guys, Travis Gillespie here. In the last video we looked at the rules of divisibility, and I suggest to my students that Hey guys, Travis Gillespie here. In the last video we looked at the rules of divisibility, and I suggest that my students memorize these rules for the rules of divisibility. Alright, now I want you to take a look at one more thing. Notice in this list, I don't have the numbers 7 or 8. The reason I don't... Alright guys, I want you to take... Test. Alright guys, I want you to take a look at this list real quick. Alright guys, I want you to take a look at this list. Alright guys, I want you to take a look at this list real quick. Notice there are two numbers that are missing. I'm just going to make some space here. Notice the rule of 7. I haven't labeled the rule of 7 or the rule of 8. These can be tricky numbers or rules. These numbers can be tricky. These numbers have kind of tricky rules. So this is what I suggest to my students. Memorize the first set of rules that I've labeled here. And when you... Now these two numbers can have tricky rules, so I'm not going to list those rules. This is my suggestion to my students. Memorize. Now these two numbers, they kind of have tricky rules, so I'm not going to list those rules. But if you're interested, look them up and learn them if you're interested. But what I suggest for my students, they memorize these first 8 rules here. And then when they've run through this list, whatever number they're given to find out if it's divisible by another number, if they're interested in finding out if it's divisible by 7 or divisible by 8, just try dividing that number by 7 and then try dividing that number by 8. If you get a whole number without a remainder, then that number is divisible by 7 or it's divisible by 8. Cool stuff. Hey guys, Travis Gillespie here. In the last video we looked at the rules of divisibility, and now we're going to move forward. Hey guys, Travis Gillespie here. In the last video we looked at the rules of divisibility, and I suggested to my students that they memorize the first 8 numbers in this list, the rules. Hey guys, Travis Gillespie here. In the last video we looked at the rules of divisibility, and for my students I suggest that they memorize the first 8 rules in this list, and then whenever they need to, try dividing the number that they've been given by 7 or 8 after they've run through the first 8 in the list. Alright, so I'm going to hide some information. And I'm going to bring some other information up on the screen. So over here on the screen, you just saw something pop up. It says prime numbers. And I've listed 13 numbers that I'm calling prime numbers. A number is said to be prime if that number is divisible by 1 and itself. So here's an example. 2 is prime because it's only divisible by the number 1 and itself. Also the same for 3, 5, 7, 11, 13, 17, 19, and all the numbers in this list. Notice there are commas separating all of these, but I forgot to put a comma here, so let's go ahead and just put one down. Now for my students, I suggest that they memorize the first 13 prime numbers in this list, and I've also broken it up into specific groups. I have the group of the ones, the numbers that are in the ones. So I suggest that my students, they memorize the first 13 numbers that are... So I suggest for my students, they memorize the first 13 prime numbers, and I've listed them here. So I suggest to my students that they memorize the first 13 prime numbers, and I've listed those numbers below. And I've also broken them into specific groups. We have the ones, teens, 20s, 30s, and then 40s. And that's just a chunking method to help people memorize information. But the reason I suggest that they memorize the first 13 prime numbers is because you're going to revisit these numbers throughout your school. And the reason I suggest that you memorize the first 13 prime numbers is you're going to revisit these numbers throughout school. You're going to be tested on them over and over. So why not just learn them now? So why not just memorize them now? Now a number can be prime if it's divisible by 1 or itself, but what if it's divisible by another number? What if it's divisible by 4, 6, 3? Now a number is said to be prime if it's only divisible by itself. Now a number is said to be prime if it's divisible by the number 1 and itself. Now a number is said to be prime if it's only divisible by 1 and itself, but what if it's divisible by another number, such as one of the numbers in this list? Well, in that case, you're not dealing with a prime number, you're dealing with a composite number, and I'm just going to write that out here. So you either have a composite number. If it's not composite, it must be prime. Cool, I'll see you in another video. All right, guys, we've been working with the rules of divisibility, and I just briefly talked about the Alright guys, in the last videos we've been looking at Hey guys, in the last videos we looked at the rules of divisibility, and then I briefly talked about prime numbers, also composite numbers. And now let's take a look at how all this information can come in handy. Hey guys, Alright guys, in the last videos we looked at the rules of divisibility, and then I briefly talked about prime numbers. I also talked about that word composite number. Now let's take a look at how all this information can come in handy. I'm just going to pop something up on the screen. I'm just going to pop some information up on the screen. And now let's take a look at the number 400. Now let's take a look at the number 462. And all I want to know is if this number is divisible by the numbers in this list. So I'm going to hide some of this information we don't need. And let's take a look at that number, 462. And let's take a look at this number, 462. Now you can run through this list a couple of ways and find out if this number is divisible by the numbers 2, 3, 4, 5, 6, 7. You could start small and work your way up to larger numbers. My suggestion is to start large and work your way down to smaller numbers, because it will speed your process up just a little bit more. Let me show you what I mean. So the rule of 12 says both rule 3 and 4 have to apply. So let's take a look at the rule of 3 for 462. The rule of 3 says the sum of the digits is divisible by 3. So I'm going to take 4 and add 6, also 2. 4 plus 6 is 10, plus 2 is 12. 12 is divisible by 3, therefore the rule of 3 works. Now there are a couple of ways you can show that this rule works. One, you could place a check mark on if it works, place an X if it doesn't, or cross that number off with an X. I like to keep my work simple, so I actually just put a circle around the numbers that work and a slash around through a number if it doesn't work. So right now we know the rule of 3 works, but now let's check out the rule of 2. So the rule of 3 works, but now let's check out the rule of 4. Well, the rule of 4 says the last 2 digits is divisible by 4. So is 62 divisible by 4? Well, the number that you would get if you divide 62 by 4 is 15.5, or 15.5. Therefore, the rule of 4 doesn't work. Since the rule of 4 doesn't work, both rule and 3 don't work together. Therefore, the rule of 12 does not work. Let's move to the rule of 10. Is 462, does it end in a 0? No, so I can cross off the rule of 10. The rule of 9 says the sum of the digits is divisible by 9. Well, 12, the sum of these digits, is not divisible by 9. Therefore, the rule of 9 doesn't work. The rule of 5 says the number has to end in a 5 or a 0. 462 does not end in 5 or 0, so the rule of 5 doesn't work. Now the rule of 6. The rule of 6 says both rules 2 and 3 have to work. We already know the rule of 3 works. Let's just find out if the rule of 2 works. Since 462 is an even number, the rule of 2 works, which makes, since both rules 2 and 3 work, since 462 is divisible by both 2 and 3, the rule of 6 has to work also. All right, but what about the rule of 7 and the rule of 8? Well, if you're interested in these two, what you could do is take 462 at this point. I'm just going to write it twice here, 462, and divide it by both 7 and 8. Divide by 7, divide by 8. And if you divide by 7, you're going to find out you get a whole number without a remainder, which is 66. The rule of 7 checks out. So you could circle this or put a check mark here if you wanted, but the rule of 7 checks out. So 7 checks out. So what you could do is circle this or just check out that 462 is divisible by 7. But what about division of 8? But what about 8? Is 462 divisible by 8? Well, our number we'd get is, or the quotient is 57.75. 0.75. This isn't a whole number, it has a remainder. Therefore, 462 is not divisible. Therefore, 462 is not divisible by 8, so I could cross that off. Cool, let's take a look at another number. How about the number 5? How about the number 540? I'm going to start big. The rule of 12. The rule of 12 says both rule 4 How about the number 540? So I'm going to start big. I'm going to start with the rule of 12. The rule of 12 says rules 3 and 4 apply. So I'm going to write 540 below and look at the rule of 4 first. Since the last two digits, 40, is divisible by 4, I know that the rule of 4 checks out, or 540 is divisible by 4. The rule of 3 says that the sum of the digits is divisible by 3, so I'm going to add 5 plus 4 plus 0, so that's nothing. So 5 plus 4 is equal to 9. 9 is divisible by 3, so 540 is divisible by 3. Since 540 is divisible by both 3 and 4, it must be divisible by 12 as well. Let's move to 10. Is 540 divisible by 10? Since this value ends in a 0, it must be divisible by 10. The rule of 9 says the sum of digits is divisible by 9. Since 5 plus 4, the sum of the digits is 9, and 9 is divisible by 9, and 9 is divisible by 9, 540 is divisible by 9. The rule of 5 says it ends in a 5 or 0, and again, 540 ends in a 0. So I'm going to circle that value. The rule of 6 says that both rules 2 and 3 have to apply. Since 540 is an even number, it's divisible by 2. Since 540 is divisible by 2 and 3, since 540 is divisible by 2 and 3, it must be divisible. Since 540 is divisible by 2 and 3, it must be divisible by 6. Now this information comes in handy. Since 540 is divisible by 2 and 3, it must be divisible by 6. But what about 7 and 8? Again, you would take 540 and divide by 7, and 540 and divide by 8. Well, 540 divided by 7. Well, 540 divided by 7, it's approximately 77.1. Since I have a remainder, 540 is not divisible by 7. 540 divided by 8 is equal to 67.5. Again, since I have a remainder, the rule of 8, or 540, is not divisible by 8. Since I have a remainder, 540 is not divisible by 8. So I'm going to cross 8 off. Now, all of this information comes in handy when trying to find out if a large number is divisible by another number or a smaller number. Because now I could take this number 540 and divide it by divide by any number that's circled in this list and get a nice whole number without a remainder as my result. And in the case of 7 and 8, I wouldn't use these numbers because I would want to keep the math simple, and I wouldn't want to get a remainder as my answer. Cool stuff. Hey guys, Travis Gillespie here. In the last videos, we've been looking at the rules of divisibility and seeing how those rules apply to larger, more complex numbers. But I'm going to get rid of this information on the screen. I'm going to keep some of it up. And I'm going to pull some other information back up on the screen. And now in these next problems, what we're going to be looking at is if a number is composite or if it's prime. So let's get started. I'm going to write the number 20. So let's get started. I'm going to write the number 23 up on screen. And I want to know if this value is composite or prime. And I want to know if this number is it composite or prime. Well, I could find out if it's composite by running through the rules of divisibility. If none of the numbers check out, also including, now let's get started. I'm going to put the number 23 up on the screen, and I want to know if this number is composite or prime. Now I could find out if it's composite by running through the rules of divisibility, also checking to make sure that 7 and 8. Now I want to know if this number is composite or prime. I could check out to, now I want to know if this number is composite or prime. Well, I could find out if it's composite by running through the rules of divisibility. If the value is not divisible by any of the numbers in this list, also including the number 7 and 8, it must be a prime number. Another way of checking if it's prime is just memorize well, since this is a small enough number, well, just memorize the first 13 numbers in your prime numbers list. 23 happens to be in the list. Therefore, 23 is a prime number. Let's take a look at another. What about the number 48? What about the number 48? Well, all I have to do to find out if this is a composite number, if it's a composite number, is just have one of the numbers in the list for the rules of divisibility to check out. Since 48 is an even number, I know it's divisible by 2, therefore it's automatically a composite number. Let's take a look at another. What about the number 31? Well, 31 also appears in the list of prime numbers. So 31 must be a prime number. And finally, one more. Let's take a look at the number 18. Again, since 18 is an even number, it must be divisible by 2. So it's a composite number. In fact, that was a little bit easy. So I'm going to put another number up on screen. What about 25? Well, since 25 ends in 5, it must be divisible by 5, and it's automatically a composite number. Cool stuff. I'll see you in another video.